Have you ever stopped to think about what it really takes to make a piece of electronics tough enough for the battlefield? I mean, it's not just about making it rugged or dropping it from a height. It's about surviving a totally invisible war, a war of energy. So let's dive right into the world of military-grade electronics certification. This is where the stakes are about as high as they can possibly get. All right, here's how we're going to break it down. We'll kick things off with this invisible threat that all electronics have to deal with. Then we'll get the lingo down, defining the key terms you need to know. After that, we'll walk through the 4 essential tests, and then we're going to zero in on the ultimate military benchmark, MIL-STD-461. And you'll definitely want to stick around for the one requirement you absolutely cannot skip for Indian defense projects. Finally, we'll tie it all together and see why this stuff is truly mission critical. Okay, first stop, let's talk about the world our devices actually live in. Because it's not empty space out there. Not at all. It's a battleground of invisible forces. You know that weird buzzing sound you get when your phone gets too close to a speaker? Yeah, that's it. That's a tiny, tiny taste of what we're talking about. Electromagnetic interference, or EMI. Now just try to imagine that, but on a massive battlefield scale. See, every single electronic device, from the phone in your pocket to a fighter jet's critical guidance system, is basically swimming in an ocean of this invisible energy. And out there, that little buzz isn't just an annoyance. No way. It's the kind of invisible static that can literally bring the most advanced systems crashing down. And believe me, this isn't just some abstract technical problem. The consequences are very, very real. If you ignore these invisible forces, you're looking at catastrophic failures, not to mention derailing entire multi-million-dollar projects. So, the bottom line is, managing this invisible battlefield, it's not optional, it's everything. So, to really get a handle on this, we need to speak the language. Let's break down the 2 most important acronyms in this whole field, EMI and EMC. They sound alike, sure, but they really represent the core problem and the ultimate goal. Just think of EMI as the bad guy. It's the unwanted electromagnetic noise or pollution that a device gives off, and it has the potential to mess with everything around it. This is the thing we're trying to control. And EMC? Well, that's the hero. EMC is the goal. A device with good EMC is like a good citizen in the electronic world. It can work perfectly fine without being bothered by its noisy neighbors, and it doesn't make too much noise itself. So to really simplify it, EMI is the loud, disruptive static. EMC is achieving harmony. It's about a device being able to do its job perfectly in the middle of all that noise, while also keeping its own noise level way down. It's all about being compatible with the world around it. So, the big question is, how do we get to EMC? Well, it all comes down to testing. Really, really rigorous testing. And the whole process can be boiled down to 4 fundamental pillars that look at what a device puts out and, just as important, what it can take. Okay, so the first 2 pillars are all about emissions. That's the noise your device is actually making. Radiated emissions are kind of like sound traveling through the air. It's interference that just broadcasts out into the space around it. Then you've got conducted emissions. Think of this like noise traveling through the pipes in a building. It's interference that gets sent down power cords and data cables, affecting other equipment that's plugged in. The other 2 pillars test for immunity, which is sometimes called susceptibility. This is the flip side of the coin. It's not about what your device gives off, it's about what it can handle. We basically blast it with energy through the air, that's radiated immunity, and we send a bunch of noise down its cables, that's conducted immunity, all to make absolutely sure it keeps working perfectly. Now, look, while pretty much all electronics need some level of EMC, the military, well, they operate on a completely different planet. And that brings us to the gold standard, the absolute peak of toughness, MIL-STD-461. Make no mistake, this is not your average commercial standard. MIL-STD-461 is, without a doubt, the toughest EMC framework on Earth. It's designed to guarantee that a radio, a missile guidance system, and a tank's engine computer can all work right next to each other in the most hostile electromagnetic environment you can possibly imagine. And just take a look at the level of detail here. The standard is broken down into dozens and dozens of specific tests, each with its own unique code, like CE 102 for conducted emissions or RS 103 for radiated susceptibility. It is a completely comprehensive, totally exhaustive regimen that leaves no stone unturned. Seriously. To really get your head around how extreme this standard is, you only need to know one number: 40 gigahertz. Now, to put that into perspective, most commercial standards, the ones your phone and laptop have to meet, they usually stop testing somewhere around 6 gigahertz. The military goes almost 7 times higher than that. So you have to ask, why? Why test is such an incredibly high frequency? It's simple, really. The battlefield is absolutely flooded with high-power signals coming from radar, from electronic jammers, from communication systems, things that civilian gadgets just never, ever have to deal with. The test environment has to mimic the real, brutal conditions of deployment. Anything less is just not good enough. So let's say you've done it. You've built an incredible product, and you're confident it meets the MIL-STD-461 standard. That's fantastic. But for anyone who's targeting Indian defense projects, there is one final, unshakable hurdle you have to clear. And here is the absolute showstopper. It doesn't matter one bit how good your own in-house tests are. For a product to even get a look in for Indian defense projects, the test data has to come from a lab that is officially accredited by NABL. That's the National Accreditation Board for Testing and Calibration Laboratories. This isn't a nice-to-have. It's the price of admission. Just let that sink in for a second. This isn't a suggestion, or a guideline, or a preference. Without that accredited test report, the entire program comes to a dead stop. It is a mandatory gateway designed to ensure the absolute highest level of trust and quality in the testing itself. And I have to be crystal clear about this. There are no workarounds. There are no exceptions. This is a black and white rule. For anyone, and I mean anyone, supplying electronics to the Indian military, NABL accreditation isn't just a step in the process, it is the only way forward, period. Okay, so let's bring this all home. We've gone from talking about invisible energy all the way to some incredibly specific, non-negotiable rules. So why? Why does all of this matter so much? Here are the key things you've got to remember. First, managing EMI is the absolute bedrock of product safety and reliability. Second, MIL-STD-461 is the undisputed champion, the benchmark for any equipment that has to survive military operations. Third, if you're working in India, NABL accreditation is the only key that unlocks the door. And finally, getting this right from the very beginning saves you from truly devastating and expensive failures down the line. At the end of the day, it really just comes down to this. Yeah, the cost of doing proper testing might seem like a lot up front, but trust me, it is nothing compared to the cost of failure. A product recall, a failed certification, or worst of all, a system malfunction in the field, that is a price nobody can afford to pay. So, all of this leaves us with one final thought. Building a product is one thing, but proving it can survive the invisible battle, that it can meet the world's toughest standards, and that it can clear every single mandatory checkpoint, that's what makes it truly mission ready. So the question is yours?